Last example in this section is one where so far they've been giving you the graph, telling you what to do, and you draw the new graph. This question, they give you the graph that you started with, they give you the graph that it ended with, and they were like basically asking what happened in between. What could have been done to do this? And I'm going to show you two methods to do this question. The first method is easier and makes more sense. At which case you probably say, why then tell us the second method? But it only works sometimes. The second method will work all the time, even in more complicated situations that we're going to see in the next section. So I want to introduce it to you already. So first of all, what do we have? We have the original one in red and the image graph in blue. And there's been some vertical and horizontal compressions. And we have to write the image graph in terms of the function f. So we need to use function notation and show the transformations. So that would be easy if we knew what happened. But if we think about what we did in our previous example, we looked at the equation, found out what we needed to do, we took some points, did what we needed to do, and found some new points. In this one, we know some original points, like we have 3, 9, and here we have 2, -8. So those are 2 points on the original graph. We don't know what happened to them, but we know where they ended up. So for example, 3, 9 ends up at 1.5, 4.5. And 2, -8, it ends up right here at 1, -4. So let's look at the x-coordinates first. Did the x-coordinates change? Yes. Okay? We're told, they give us the hint, that it's a compression. So you know x is getting multiplied by something, but that would be one thing in another question they might not tell you. So you might think, oh, it went down it went left 1.5. But do you see that that doesn't work for the second point? The second point only went left 1. Is there something I could multiply the first point by to get 1.5? Yes.
0.5.
0.5 or 1/2. Does that work for the second point as well? Absolutely. So now we know that the x has been multiplied by 1/2. Similarly, look at your y's. I think you'll see it quite easily that that also has been multiplied by 1/2. Then when we want to go and write the equation for the blue one, y's aren't liars. They happen outside, so that 1/2 happens outside. The x's are liars, so inside, we're not going to write 1/2. What are we going to write instead? A 2. So this is the equation of the blue graph in terms of f. So that in terms of f part is telling us we have f on the right-hand side of our equation. Okay? So anytime you see this in terms of, it's telling you that has to appear on the right-hand side of your equation. So we have the 1/2 out in front for the vertical compression, and we have the 2 inside for the horizontal compression. When we get to more complicated ones, this will be the strategy that we'll use. And this will come into play when we're going to do more things. We're going to compress it and then move it. And if you compress it and move it, you will not be able to immediately just see what happened because too much math has happened. But if we compare horizontal distances, and for this one, I'm going to label this as point A and this as point B. And on the image graph, then we write A and B with a little tiny line. Says A prime and B prime, saying A changed to here, B changed to here. And in our comparison, we start by looking, what is the horizontal distance on the original graph? If you went from A to B, you go from 2 to 3, you would go right 1. I'm going to put a plus sign there to say to the right. If you went to the left, you put a negative sign. Do you need the plus sign? No, because it's positive either way. But just to say, I'm going to the right. And if I look at what happens from A prime to B prime, here I'm going from 1 to 1.5. That would be plus 0.5. How do you go from 1 to 0.5? You would have to multiply your x values by 1/2 to change that horizontal distance from 1 to 0.5. And we're going to have to do the same thing with our vertical distances. If we look at our original graph, the red one from A to B, we start at -8, and we go all the way up to 9. And you see that that means you have gone up 17. And when we compare A prime to B prime, A prime is at -4 all the way up to 4.5. That's up 8.5. And again, to go from 17 to 8.5 is y by 1/2. So can you see why the first method in this situation is nicer, right? It's connected to what you did before. It's easy to do the mental math and find it out. Okay? Later on, this method of comparing horizontal distances will be necessary to do this. But I'll show that to you later. Yes?
Why is it mean that y equals 1/2 at the answer? Why is it 2?
What's that?
Why is it a 2?
Why is this one a 2? Because x's are liars. So every time you have a 2 inside, you multiply by the reciprocal. Okay? And the reciprocal of 2 over 1 would be 1 over 2. Reciprocal just means we flip the fraction. So in this question, when we were checking what happened to the x values, they went from 3 to 1.5. The x values got multiplied by 1/2. So in reality, they got multiplied by 1/2. In the equation then, because the x's are liars, we need to have a 2 there. All right, questions to circle on this one. 5, 12, 13, and 14.